Hi everyone, welcome back to the channel. In this series where we discuss about the activation function, today let's try to learn about softmax function. So what is softmax function and where is it being used in AI? So if you look at the equation of the softmax function, you can see that this is how it looks, right? It looks pretty complicated. Before directly diving into the math behind the softmax function, let's try to understand where it is being used and why it is needed. It's a relatively very simple concept. It doesn't take much time to understand. So let's say you built a neural network and then you're trying to predict to which class or which house does a Harry Potter character belong to. So given an input image, the neural network tries to predict to which house that character belongs to. So given the image of Harry himself, we are ideally expecting the neural network to predict Gryffindor. But the problem is that you can't pass an image as we see it to the neural network. A neural network can take in only an image and it can't predict a word as such. It's going to give you a number as an output. So basically the neural network takes in a number and it predicts a number. So the input to a neural network is going to be a number and then output is again going to be a number, right? So what happens is we'll be converting the image to an array. So the image that you see here will get converted to something like this. I mean, not exactly this, but something very similar. And once we convert that to an image, this is the input that goes to the neural network, right? And once that image goes in, the neural network makes a prediction. So as you can see here, the number which represents the image or the tensor which represents the image, it goes into the neural network and you get a prediction, which is again a number. So since we have four houses, that is Gryffindor, Slytherin, Hufflepuff and Ravenclaw, we'll be having four nodes at the end. So these are nothing but the neurons. So you'll be having four neurons at the end and each neuron will give you a number. But then how do you map this number to the output? Because you don't want the number as an output, right? So ideally, if you get a number like this or an array like this, how do you understand which is the class, or in this case, which is the house that the neural network is referring to, right? What does 81 mean? Does it mean Gryffindor? Or what does -2 mean? Does it mean Slytherin? You don't have any mechanism to identify what the number indicates, right? So this is where you use a softmax function. So what you basically do with softmax function is you use the output value that is being predicted, you use this number and you map it to probability values using softmax. So the output array that you get here, it essentially gets converted to a probability value. So let's say if Harry, the probability of Harry belonging to Gryffindor is high, the value, that probability value that the softmax function gives you will be very high. So there'll be like 0.99 or 0.9 or 0.8 depending on your neural network architecture. That is 80 to 90% or whatever chances of Harry belonging to Gryffindor. So the output, this array that you see here, is nothing but the output of neural network It goes through Softmax, and then you get prob values of characters belonging to a house. So now let's look at the math behind it. So how does it work? So if you look here, it says e power zi divided by summation of j equal to 1 to k e power zj. So what does that mean, right? So it's nothing but z here indicates the value. So each of the value that you see here, that is 81, minus 2, 23, 4, it's nothing but the zi values, right? And zj is nothing but the this entire thing that you see here at the bottom is nothing but the sum of all these values. Exponential of the number, and then you take the sum of it. So basically what you're trying to do is, if you want to know what does 81 indicate, so this is nothing but softmax of 81 will be equal to e power 81 divided by e power 81 again plus e power minus 2 plus e power 23 plus e power 4. In this case, I guess it will be very close to 100, that is 0.99999, etc. So basically what you're doing is, given a number, you've converted it into a probability value, and all these numbers that you pass here, let's say the second number, it will be nothing but sigma, softmax of minus 2 equal to e power minus 2 divided by e power 81 plus e power minus 2 plus e power 23 plus e power 4. I guess this probability is going to be very less, since it's already 0.99. Every probability value that you get, the sum of all the outputs of the softmax, it sums to 1, right? So that will be equal to 0.0000, etc., some value, right? So basically how you map the output is, so given a number, given an array like this, you have 81, 20, minus 2, 23, 4, and this value, once it goes to softmax, will get converted to prob value. Let's say 0.999, 0.000, 0.000 again, 000 some value, maybe 2, 3, and 0.0000 some other value, 15, right? So you got all the probability values. Now you already have a predefined classes, right? So basically, let's say you have a list like Gryffindor, Slytherin, Hufflepuff, Ravenclaw, etc. So basically what you do is, you look for the index of the value which has the maximum probability. In this case, it is the 0th index, or the first value, or the 0th index, when you think about it in Python terms. So you go to the predefined classes and you fetch the value that belongs to the index 0, and it'll give you the output Gryffindor. So before you train the model, this will already be defined, because this is the class that you're trying to predict. and everything else the model learns, and then it gives you the prediction. So if your model training has been good, ideally you should get a really good probabilistic value for the Gryffindor when you pass the image of Harry. So now let's just switch to the code, and I'll just try to explain how the code part works, right? So here I have few codes already written, and then it tries to explain what is this. So I'm just importing few libraries. Basically, I'm just importing computer vision, which is not being used here, but NumPy, PyTorch, and from the PyTorch, I'm again importing Softmax. It's ready. The Softmax is readily available. Let's say this is the same value that has been predicted, 81 minus 223, 4. So this is the same value that you got from the neural network that tries to predict the houses of a Harry Potter character, right? So let's go to this part of the code first. What is defining softmax? So this is a custom function that I've written. So basically what it does is it takes an array of element, that is the z value, and then it calculates. The numerator is nothing but it, for every element it calculates the exponential value. So here, if you see here, you're calculating the exponential value. This is the numerator. So it calculates the exponential value, and the denominator value is nothing but the sum of all the exponential values. So this part that you see here is same as this part. Sorry, it's same as this, the bottom part that you see here. This is same as this, right? And then you predict the output. So let's just pass the output through the softmax function and see how it is predicting, and you get the prediction, right? See, as I said, the first value, which is corresponding to the 81, it's almost equal to 1. The rest of the values are, so E here represents 10 power minus 37. So this is 10 power minus 26. This is 10 power minus 34. So this is basically 0.000000003. This is 0.0000006, whatnot. So that's how the softmax prediction comes. We have, so rather than defining a custom function, you can also try to predict it using the function available on PyTorch. So here I'm importing the softmax function from torch.nn, and I'm creating, it's actually a class, so I'm creating an instance called sft, and here I'll try to predict the output for that using the torch.tensor. So if you compare the output that we got from TensorFlow's inbuilt softmax function and the custom function that we defined, it's the same. So as you see here, it's 1.000 and 8.95, etc., into 10 power minus 7 to minus 37. Same thing here. The minor difference that you see here, it's because of the rounding off of the floating point. They handle it pretty well, not like how I've defined it here. But if you look at it, essentially the output is same. It's 1, 8.98, 6.47 into 10 power minus 26, etc., etc. Now, you can go ahead and delete this cell. Now, how do you predict the class? So, as I said here, you will have something like this output class. My bad. Equal to Gryffindor Slytherin Hufflepuff Ravenclaw, right? What you do is you pass the output, you get the index of the output from the softmax function, and then you pass it to the output class. So prediction will be equal to output class of np.argmax softmax of z, right? I'm sorry, my bad, it's out class, not output class, right? And you look at the prediction, it says Gryffindor. So that's a great prediction. So you got the output that Harry belongs to Gryffindor. So I hope you understood the math behind the softmax and how it is being used. So the basic idea is, given the prediction of the neural network, which is nothing but a bunch of numbers, you essentially pass in numbers and you get numbers as an output. So numbers in and numbers out. So you use the softmax function to map it to a probability value so that you can interpret what the neural network is trying to convey to you. And then you use the output class, which has already been defined. And then you use that to get the prediction. This video is clear. If you are new to the channel, please consider subscribing. And please share the video with your friends and then leave a thumbs up if you actually think this was worth your time. Thank you so much.